Hello everybody, this is Khashayar and welcome to part 5 for game developing with Python and Pygame. And as you see, this is what we got from last video, and for now I'm going to tweak the bouncing a little bit, and in this video we are going to write the collision between ball and the paddle, and can be somehow done with the logic of the game. So from next video we will import external image and add some sound effects, and we will finish it with some on-screen text and scoring some minor problems. Okay, the first thing I need to do, I want to make the ball go through all the way down if we don't catch it, and come back from top of the screen. So here I need to get rid of this. So instead we write if self.rect.top greater or equal height, then self.rect.bottom equal 0. Now it will pass from bottom of the screen and come back from top. The reason we need to do that, actually I like to do it because you can write the game in many different ways. For example, if we can't catch it after we write our collision, it will go and we can stop the game by time and write a screen message like, oh, okay, you lost, or you lost the score or something like that, and after continue the game and come back from the top, or we can have some random position for the ball, and so you can't predict the upcoming position. So then now we going to have collision, and here we say if. For collision, actually for collision in Pygame there are many ways, and especially when you are using sprite group, normally they are using a group collision, but that can be also okay, but it's more fit to those kind of games like you are dealing with too many objects, and you can use group collision, for example. But now for this particular collision, I think the rect collision is enough. So basically it's calculating the edge of the rectangles between two objects, and when they are met you will have the collision. So let's say if self.rect.collide rect, and here you have to pass the second object, which is player.rect. Then self.yspeed multiply equal -1. Okay, it's going up and never come back. I don't know if you could catch it, or let me show you one more time, because now we need to tweak our logic a little bit and add one more attribute in the class. Look, the ball is bouncing back, but when it's going on top of the screen, never come back. Now you might think, okay, we can write something like this. So if self dot rect dot top smaller or equal than 0, then self dot y speed multiply equal -1, and that can fix the problem. Yeah, let's see. No, it can't fix the problem, because now the ball is stuck between two if statements. So it should be somewhere here. And maybe you think, okay, we can write elif, and you might ask why I'm not using elif and I'm using if all the way down. Because when you're using elif, the Python is checking for only condition which met the requirements. But when you use if, Pygame or Python is checking all the conditions all the way. Sometimes we need to program to check everything, not just check one particular what is met to the requirements. And as a when maybe someone say, okay, but there will be like faster process or less memory usage, but in this kind of program and with this kind of hardware what we have now, for a couple of lines it doesn't really matter. So now again, and still I think you can see the ball is bouncing here, try to come up, come down, and met another condition going up, met another condition going down, and because of that it's just stuck here. So let's put them back. Now what we need to do is we need to use a flag. So say direction flag, and it can be boolean or it can be string or how you want it. Self dot direction is just a variable equal down. I use string, and let's comment here. We say horizontal bounds, and here say vertical bounds, and say collision, and get rid of this line here. So now we have nothing to do with this horizontal bounds, we have to take care of vertical. So if here we can add one more line, if self dot direction equal down, then if self direct dot top greater or equal height, then self direct bottom will be 0 and the ball will come back from top of the screen. And also if they met, collide, it will go up. And here we should say, add one line more, self dot direction equal up. So we are changing the flag. And here we say if self dot direction equal up, and if equal up, and if self dot top rect dot top smaller or equal 0, then self dot y speed multiply equal -1, and self dot direction equal down. So we just set back the direction flag to down normal. Now we have the bounds. It will go up and come back, and when we don't catch it, it will come back from top. One thing what we can do, we can make this line a little bit shorter. Say if self direction equal up and self dot rect dot top smaller than or equal 0, then self dot y speed multiply equal -1 and self dot direction equal up down. So we can have a little bit shorter line. And something important here, writing very compact and short codes or compact codes is not necessarily a good thing. The functionality of code and readability of the code is more important than when you try to write everything very compact. Of course, you need to have more skills to write more compact code, but in my opinion, the readability and simplicity and functionality of the code is most important. Okay, let's try it one more time if everything works okay. So we have the basic working game now. So the logic of the game is kind of complete. We just need to add some score, some on-screen text, and use some external image and bleed them on the screen, and sound effects and something else I'm going to do in the next video, hopefully. I want when this ball punching the paddle go a little bit down and come back up, so we can have a feeling of the punch, like something's pressing it down and just press it back, so something like that. Okay, thank you for watching, and I see you in next video.